Yeah, hello everyone. This is ASN Raju, and we are proceeding towards the topic sensors. And I would like to deal with motion sensors and temperature sensors, magnetic and light sensors in the today's class. Generally, what are the measuring quantities and what are the stimulus to or measurements utilized to measure and the quantity which is to be measured will be having a glance regarding it once. Acoustic. Acoustic is nothing but the sound waves or the voice frequency variations that has been done at different levels. And for that, the wave fluctuations will be monitored, amplitude or phase polarization of the parts of the wave fluctuations, spectrums and wave velocity. And in the case of these biological and chemical parameters, fluid concentrations such as gases or liquids has been monitored. And in the case of these electrical stimulus, the parameters such as charge, voltage, current, electrical field such as amplitude, phase polarization, conductivity, permittivity, capacity will be measured. In the case of these magnetic type of stimulus, magnetic field variations, flux generations, magnetic permeability is measured with respect to the quantity. And in the case of this optical refractive index, the reflections, absorptions, emissions also will be measured. In the case of thermal, temperature, flux, specific heat, and thermal conductivity. Coming to the mechanical point of view, position sensors, velocity, acceleration, forces, stress, strain, pressure, torque, RPM, etc. will be used for the quantity measurement. Just we will have a look about these physical parameters in the case of electrical mode of operations and even the optical sources or light rays. Here we will be looking with Ampere's law. A current carrying conductor in a magnetic field experiences a force. It is a galvanometer. The Curie's law is the transition of temperature at which ferromagnetic materials exhibits a paramagnetic behavior. So ferromagnetic in the sense will generates the fluctuations and that need to be identified with the producing current existing in the present containing magnetic behavior. So this paramagnetic behavior. Moving on to the Faraday's laws, the coil resists a change in magnetic field by generating an opposing voltage or current. Nothing but an example is transformer. When the excitation has been commenced on the primary coil simultaneously in the depending on the mutual inductance. By the process of the mutual inductance, the EMF will be produced on the secondary coil windings also. And moving on to the photoconductive effect, when the light strikes certain semiconductor materials and the resistance of the materials will be decreases, that is photoresistor. And how the sensor need to be chosen, on what factors these sensors need to be chosen, and what are the characteristics need to be identified, and depending upon which environmental conditions these parameters need to be obtained. We'll be having a small glance regarding it. The temperature sensors, environmental basis of factors, temperature range that is changing with respect to the climatic conditions as per the seasonal variations such as summer, winter, rainy, etc. Humidity effects, and within the open room, open containing rooms or enclosed rooms are open to the atmospheric criteria. Corrosions, corrosions are nothing but the blocking of the passages by the incorporation of the slurry materials on the runway, and depending upon the dimensions, there are sizes, different sizes, overrange protections, susceptibility of engineering material interfaces, ruggednesses, power consumptions, self-test capabilities. Moving on to the economical factors, as per the cost basis, that is the manufacturing of that particular sensors and operating parameters with respect to the economical range, that is nothing but the cost differences, either it may be increased or a medium range or a maximum level need to be maintained. And another one more, it is if the investment has been done in a high range and for operational parameters it has been increased, how how long those sensors will be existing upon operational basis. So the investment will be calculated apart with the maintenance and will be equated to the performance of that particular component and how come or how long that operational conditions will be maintained. And these and all some of the parameters or factors coming under the economical zone. And next, moving on to the sensor characteristics and upon the performance, what are the required output conditions need to be satisfied as an output to the operator or analyst. First one is the sensitivity, accuracy, range, stability, repeatability, linearity, error, error rectifications, reference zones, response time, frequency response. And these are the some of the sensor characteristics or parameters of the sensors need to be satisfied upon the operational basis when any of the sensors that has been discussed in the earlier, uh, that is magnetic level sensors, electrical sensors, photoelectric sensors, optical sensors, radiographic sensors, ultrasonic sensors, etc. Whatever it may. So upon the operational basis, these are the characteristics need to be satisfied in the working scenario. And depending upon these criteria by the environmental basis and for a suitable environment, certain economical factors need to be verified, and depending upon that conditions, whether that particular sensor will be able to satisfy the overall these characterizations such as sensitivity, range, stability, repeatability, etc. Just we have been discussed or not will be verified, and later on the simulation activity will be progressed, and if at all it has been succeeded, moving on to the maximum or major production unit. Yeah, here is the question: why the need of these sensors? Sensors are pervasive, embedded in our automobiles, airplanes, cellulars. There is a contact mode either in the contact type of mode or non-contact type of mode. And without the use of sensors, there will be no automation. So without human involvement in the sense, indeed to actuate like as in human beings, the artificial intelligence will be a part of this microcontroller, and as per the processor instructions, controller will take the ultimate decisions what the next step need to be maintained in an automobile. Similarly, as like of the human decisions. Yeah, here is the monitor locations. The monitor locations of various parts in the system has been shown here. Absolute or relative position, angular or relative displacement, proximity conditions, accelerations. Using all the examples already, this proximity sensors have been looked away. Displacement sensors are also have been analyzed once. Accelerations, there is nothing but measuring of the speed or RPM of a particular automobile. And beyond this all, what is the basic principle of operation in the sense the magnetic source, resistive, capacitive, inductive, electrical current, etc. These are the major principle of operations that the techniques will be calling as in techniques utilized indeed to drive these different parts. So looking after this potentiometer upon orientations, the magnetic inductance will be getting generated within the internal parts of the equipment setup, and the primary coil ignitations will impart the electrical flux generation upon the orientation of this particular magnetic coil in between the electrical windings, and hence the impedance will be generated, EMF will be getting produced. So that EMF will increase furtherly and output range in the form of voltage increases. So this increases in the voltage creates the increment in the RPM also. So excitation of or movement of this magnetic coil or core within the primary coil to the secondary coils. The excitation within the secondary coils due to the mutual inductance, the high amount of voltage will be getting generated as shown in the diagrammatically, and this output voltage is doubled than the input voltage, and hence if the voltage as an input is equal to 1, the generated voltage will be 2, and hence it will be increasing furtherly in the case of RPM or in the case of output. So in the case of this strain gauge, we already discussed earlier that strain gauge is used for measurement of different types of stresses that has occurred suddenly in the particular regions due to some application of forces or application of pressures or high deflections has been considered due to the application of high stress levels on a particular object. So these strain gauges will be placed over there, and the expansion of this gauge length will be getting happened when the gauge width has been minuted with respect to the application of forces towards its top and bottom directions. Simultaneously, these connecting rods will be getting expanded in both the directions, and if it has been restricted in the otherwise other direction, only at one direction, that is minus x-axis, the incremental strategy will be taking place. So indeed to safeguard the terminals, the insulating layer and bonding cement will be applied on the terminals, and the resistance of the sensing elements change with respect to the application of stress or even the strain values also. So next one is moving on with respect to the temperature measurements. So here temperature measurements initially ring-like structures will be utilized, and later on uniformity of the material has been utilized such as copper, silver, argentina, silicon, germanium as an unique materials, and later on changed to a bimetallic strips. So similar kind of materials can be utilized as a metal A and metal B, or the opposite materials also can be utilized as a metal A and metal B. So equal materials or similar materials or dissimilar kind of materials can be utilized. And upon the utilization of dissimilar kind of materials, those materials will be getting strained upon the application of similar thermal capabilities, but the results or parametric changes will be varied with respect to the material A and material B. For example, if you have been considered this metal A as in copper and metal B as in boron, boron will be having the highest carbon capability when compared to the copper, and copper is having the high ductility capacity when compared to the boron. Upon incrementing of the temperature, simultaneously incrementing of the temperature leads to the application of stresses in the case of thermal strategy towards the metal A and metal B simultaneously. The changes that has been commencing in the metal A is very much faster when compared to the metal B, such as copper to the cadmium material. So initially the metal A will be getting strained. That is nothing but expansion will be getting done initially, and later on metal B will be taking place. So at an ultimate level, metal A gets to transform a maximum range at a maximum range, it will be transforms to a liquid phase a bit earlier when compared to the cadmium. So those are the basic differences, and where it will be applied. So application leads to the thermostats, makes or breaks the electrical connection with the reflections. And here is the formula, that is L is equal to L naught of 1 plus beta of major temperature to the obtained temperature T minus T naught. So the temperature sensors looks like this. So next one is, and next one of the type of temperature sensor is RTD, resistance temperature device, RTD. When the similar formulation here need to be found, the found or obtained results upon the operational procedure. Next one is the thermistor, simultaneously the thermocouple. So insulating material will be the same, but two different wires will be insulated with respect to a single strategy as displayed in the diagrammatical source. Next one is an accelerometer. Moving on to the speed range of sensors. Speed sensors. Accelerometers are used to measure the speed. So major applications here, motion analysis, vibrational strategies, blast conditions, impact conditions, shock wave proofs will be identified. So we need to find out the vehicle speed. Vehicle speed will be utilizing these particular accelerometers, and these are having with two different connectivities or display outputs, two different display outputs. First one, it is the analog kind of display, And second one, it is the digital kind of display. The basic difference here is incorporation of converters or transducer, which transforms from the physical parameter from one form to the another form. There is physical phase of parameter to the digital phase of parameter. That is A to D converter, log to digital converter. Simultaneously, if the mode has to be changed, will be utilized for as and vice versa. That is digital to analog as well. So this accelerometer working nature. So it's a device used to measure the dynamical motions or forces. So the static forces like gravity pulling, lying at the table. Dynamic forces caused by motion or vibrations. So how they will be work? It's a basic phenomena. There is seismic mass accelerometer. So seismic mass accelerometer is connected under the acceleration conditions to a spring or a damper. So damper, just the equipment setup we will be calling as an shock absorbing devices, shock absorbers, piezoelectric accelerators, piezoelectric accelerators. A crystalline structure is mounted on a mass undergoing the accelerations. So upon sudden damping conditions, the acceleration forces are produced a voltage signal, and beyond a signal pulse, the controller or analyzer will stabilize the observed force in the form of a voltage and displays on the screen. And simultaneously the capacitive accelerometers, it consists of two microstructures forming a capacitor. That is micro machined features with the micro machined features, and those acceleration forces move one of the structure causing within capacitive changes. So one will be getting changed with respect to n capacitive forces as per the acceleration forces has been applied, and one will be as an in the ideal strategy. Simultaneously, these thermal accelerometers, this tracks location of a heated mass during acceleration by temperature sensings. So the sudden impact at the vibrating strategy when the mass has been applied, that heat produced at that particular device mass characterizations or the damping device will be identified, and depending upon that, the results will be getting analyzed. Yes, automotive conditions. In the case of automotive conditions, motor vehicles tilts, rolling, skidding, impact, vibrations, etc. creates the deploy safety devices, and to ensure the comfortable ride also even these are used for in the aerospace conditions, usually utilized for internal navigations, smart munitions, unnamed vehicles. So even some it will be applied in the sports and gaming, personal electronics, security conditions where the motion and vibration detections are being taking place, and in the industrial basis, and mostly in the robotic devices. Yeah, this and MX2 utilized in MEMS is the conditions or the strategies or application of these particular sensors in the case of MEMS. These are the devices consisting of a chamber of gas with an heating element in the center, just as shown or displayed in the diagrams as shown below. Four temperature sensors around its edge towards its four different stages as per the square representations, and at the center the heating elements will be accessed. And here hold accelerometer level, tilt the accelerometer, and MX2125 Electronics compares the difference measurements and generate the output pulses. This pulse duration ends the sensor outputs. So how will we just have a glance over these old accelerometer levels? So hot gas packet rises to the top center of the accelerometer chamber. All these sensors measure the same temperature. So similar temperature will be measured, but not the variations or fluctuations, even it has been tilted to or surrounding you towards its 360 degrees orientational basis. We are moving on to the light sensors, how the light sensors are utilized in the mechatronic systems and where it will be utilized and how the detection process will be getting done. We'll be having a just look over these light sensors. These are used in cameras, infrared detectors, ambient lighting applications. Basically, these are composed with a photoconductor such as photodiodes, transistors, resistors. Coming to the working point of view, the sensitivity will be variable towards the resistors, and that resistance depends upon the intensity of the light rays. So, under the two different conditions, first one it is in dark condition, and second one it is in bright conditions. The resistance is quite very high. When the resistance has been very high, then it is called a dark resistance, and when the resistance is low, it's called few hundred, or else the bright conditions. Coming to the factor of response time, when a photoresistor is exposed to the light, it takes a few milliseconds before it lowers its resistance. And for the experiencing of the removal of light, vice versa, it may take a few seconds to return back to its dark resistance. But it will be invisible with respect to our naked eye. That the observance it itself specifies the difference between these two different parameters, considering towards the brightness or towards the darkness conditions, that is response time basis. Basically, these photoresistors exhibits a non-linear characterizations for incident optical illumination versus the resulting resistance. The graphical representation and the values that has been obtained will be plotted on the graph as shown below, and the calculation characterizations will be done with respect to a formula that is log 10 or is equal to alpha minus beta log 10. Moving on to the magnetic field sensors. The magnetic field sensors are used for power steering conditions, security basis, current measurement on transmission of different light lines. So Hall voltage or Hall effect conditions Hall voltage is directly proportional to the magnetic field that is being generated, and the magnetic field at respect to the Hall voltage is measured with respect to or calculated with respect to a formula that is IB by NQT, where the induced current with respect to the battery reference source to the generated pulse with respect within the time and n number of times it has been repeated. Yeah, here is the next type of sensor. It is an ultrasonic sensors. Just we have been discussed in the previous class also. And let us see in depth how frequency need to be pointed at what range of frequency it is being operated, and which conditions and in how many types of zones we will be utilizing these ultrasonic sensors. These are the sensors used for position measurements. Sound waves emits are in the range of 2 to 13 megahertz, and maximum it can be extended indeed to find out to 20 megahertz of frequency. Sound navigation and ranging sonar and radio detection and ranging sensors, that is radar systems, electromagnetic waves. Yes, these photogates are used in counting applications. So n number of services that has been passed on internally or through that particular photogate will be counted, and the infrared transmitter and receiver at opposite ends of the sensors, and the time to which the light is broken is recorded. So when the object that has been passed internally, that cuts the light passage from one gate offense to the another gate offense, that is in the receivers at the opposite ends of the sensors. So when that light source has been disconnected from one end of the sensor to another end of sensor, simultaneously it detects that one pulse has been generated or one count has been taken place. So continuously, as a form of chain systemic device, it will be going on. So it's an photogate systems. Thank you.